Good morning, one and all present here. I am Nandini D, working as an assistant professor in SNS College of Engineering at the Department of Computer Science and Technology. Today, we are going to see a topic in deadlock in database management system. Let us see what is a deadlock. For example, deadlock is a system in which there exists a set of transactions. For that, each and every transaction is waiting for another transaction in a set to get some of the situations. None of the transactions can make progress in a situation. For that, if suppose there are 2 to 3 transactions, one transaction should intimate whether it has been completed, finished, it is successful or not. If these intimations be sent to the another transaction, then it can start this another transaction's work. This only remedy is to undo a condition if a system to invoke some dramatic action such as rolling back systems. There are for example, we are showing a bridge cross example. In this example, there is we can imagine as a 3 image. One side at the narrow end only 2 cars are going. At the right side there are 2 cars coming with a wider transaction, and in the left side there is a 1 car coming in a wider transaction. There, this situation we can say is as a deadlock situation, because at the center narrow part that 2 cars must come out. Before that, if some other cars are coming there will be some deadlock will occur. So that we should wait till that 2 cars come out, or if 1 car come out, it is intimating the other car wait for one situation. Here is 1 car, it should get out of this. Like that, if it gets intimated, we can easily grow this. There are some characteristics in it. For example, we can say as a mutual exclusion, hold and wait, no permission, circular wait. Like this, there are many processes. There are 2 methods for dealing with deadlock. One is deadlock prevention, another one is deadlock reduction and recovery. Let us see what is deadlock prevention. It is an approach that has no cyclic waits that can occur in ordering the request for locks. In which order the locks are being getting request, at that order or like that purposes it is been requesting for the locks. For example, we are taking a simple example for deadlock prevention. One is one transaction without ordering locking. Another example we are going to see is with order locking. In that, T1, which is known as lock A, request a lock on account B. T2, which is lock B, that request a lock on account A. Both are waiting for each other to release the locks. They two are waiting for each other to release the lock. To prevent cyclic waits, system ensures an order which lock must be acquired. First, it is asking which locks to get solved. Always lock account is ascending order. We should assume that it must be in an ascending order of their account numbers. So that rule T1 transactional locks account A, so that the account B is waiting. So T2 also follow the same order near lock account B before account A is getting unlocked. Ensure that a cyclic dependency never occurs, preventing the deadlock. So there is another approach. It is also known as a second approach. In that second approach, we are going to see rollback of transaction. For that, an example has been given. 2 commonly used schemes are wait dead and wound wait. Wait dead is also known as a non-primitive approach, and a wound wait is also known as a primitive approach. When P requested a resource currently held by Q, P is allowed to wait only if it is older than Q, otherwise P is known as a rollback. But in wound wait, when P requests a resource currently held by Q, P is allowing to wait only if P is younger than Q, otherwise Q is rolled back. And this what they are coming to say is, in wait that P is requesting currently to another one transaction, requesting to another transaction. That one transaction waits till this Q gets older. Gets older means its transaction is being finished, or otherwise this P gets die. Okay, the transaction is not been, I am going to die. In the wound wait, P requested to Q. So here what this means, if P is younger than Q, that means P is not Q is not currently working, so it is younger than Q. Otherwise, it gets wounded. In this 2 schemes, wait and so for example, we are going to see here, we are going to see an wound scheme. In this wound screen, we are going to see a one situation. Wait die scheme. It is a non-primitive debt for rule 1. If a older transaction requests a resource held by an younger transaction, it waits. So older transaction means if one transaction is going to get completed, for that other transaction has been waiting. If an younger transaction requests a resource held by an older transaction, it dies. So if one is requesting by an older transaction, it gets dies. So for example, online shopping we are going, in that we are taking two phases. One is lock item, another one is processing payment. For example, a older transaction starts its transaction at 10:01, adds a laptop to the cart and start checking out. And the other transaction, which is younger transaction B, it starts at 10:05 a.m. also tries to add same laptop to the cart. So on this, this is one situation. And the second situation is older transaction. A requests a resource held by younger transaction. A is older, allowed to wait. User B completes or releases the resources. So if one complete the whole resources, B is been waiting for that moment. After A completes his resources, B gets resourced. So next one, younger transaction, which requests a resource held by an older transaction A. User B is younger, it dies. Suppose it is younger, it get dies at that situation. To avoid that deadlock, we are going deadlock avoidance. Deadlock avoidance mechanism can be used to detect the deadlock situation in an advance. So if there any situation occurs, how we can prevent and how we can avoid that, we are going to we are using that in that place. For example, we are giving a card with bank, one user, ATM, consumer, bank. So it shows how before using it we are enclosing it. Thank you so much.